Wait, I will start the class soon. Mm. Just wait, huh? So in the last class, we discussed about the how to split single phase supply into two phase supply and use it for making single phase motor as a self starting. Okay, so now I'll share you the screen. So we have seen the basic how that single phase supply can be splitted into two phase. So we had discussed about different types of motor like a split phase motor, capacitor start motor, capacitor start, capacitor run motor. So these three types we have studied. Okay. So now let us study about the split phase induction motor. Split phase induction motor. Single phase, please type split phase induction motors. Okay, so in this motor, what is done is like this. We have two windings. This is the auxiliary winding or a starting winding. Some books may call it as a starting winding. This is a running winding, or some book may call it as a running winding, or some book may call it as a main winding. Okay, and this is my single phase supply. Okay, and this switch is called as centrifugal switch. Centrifugal switch. CS is a centrifugal switch. Okay. And this is my rotor. Squirrel cage rotors are there. Okay. So this is rotor. And both windings are there in the stator. So stator has two windings. Two windings. Okay. One is starting winding and another is a running winding. Okay. So starting and running winding. Okay. When you connect, now see the main winding, say this current flow through this main winding is say IM, and through this auxiliary winding is say IA. IA, auxiliary winding, and total current from the source is say I. Okay. This auxiliary winding, we are connecting external resistance normally. We will have external resistance. Clear? And this is a winding itself, winding resistance. This resistance is a winding. So the auxiliary winding has more resistance. Okay? Or make more resistive. For that, external resistance will be connected. External resistance may be connected, may be connected. External resistance may be connected. Clear? So actually it has more resistance and low reactance. That is the property. Main winding low resistive, low resistance. That is the property. Hmm? Now this is the property. So what will happen? Say this is my voltage. Then what will happen to this auxiliary current IA? It will be more close to the voltage because it is having higher resistance. Okay? And this is having low resistance and relatively more inductance. Relatively more inductance, relative value. So what will happen? So current through this main winding will be lagging behind by more angle. Okay, say IM. So this angle will be much more than this angle. Clear? Now if I can add this together and you get this as a I. So this will be the power factor phi. And this is the theta, which is angle between two currents. Hmm? Okay. Now this theta, which is not 90 degree, which is not 90 degree, maybe 50 degree, 60 degree or something like that. But it is capable to produce rotating field. Phase theta, phase difference theta is sufficient to produce rotating field. Okay, it is capable, maybe around 50 degree, 40 degree or something like that, around that. So rotating field. What will happen? The currents are different, so it may not have a uniform rotating field, but it will have a rotating field. That is there. Now, 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 what will happen? Because of this rotating field, the rotor will start rotating. Okay, the centrifugal switch actually. This switch has a property when the speed is around 70%, that depends upon your setting, 70 to 80%, that time that switch opens. When the speed is around 70 to 80%, the switch opens, otherwise remain closed. Okay? At this speed, the switch opens, otherwise remains closed. So now what will happen? Because of this phase difference, sufficient to produce a rotating field, a rotor will start rotating and will try to reach to the high speed. Okay? And at that speed, 70 to 80% of the speed, the centrifugal switch will open. The centrifugal switch will open and it will disconnect this auxiliary winding. So under running condition, only the main winding will be there. Only main winding will be there. Okay. So this is how our motor will operate. Now, uh, how the motor continue to rotate, how the motor continue to rotate just on one flux. To understand it, you have to study double field revolving theory. Just note. Okay. So that explains you while only one flux exists and rotor was already in a rotation. Under that condition, how the motor continued rotate. To understand that phenomena, you have to study double field revolving theory. So I will not teach you that double field revolving theory because of the time restrictions. You can study from that, any book. Double field revolving theory. Okay? That you can get from any textbooks and you can understand this how this flux, single flux is making the rotation continuously. Clear? So that you have to study from that double field revolving theory. Basically, I'll just give you a hint. Just give you a hint on the next. Okay, next. See, I'll save this and I'll just try to make you understand, convince. Just wait 1 minute. So I'll just give you a hint. So in double field revolving theory, okay. So see double field revolving theory, I'll just try to make you understand. Whether you understand it or not, just forget. But what it says that pulsating or alternating field can be divided, that pulsating field can be divided into two halls. It is rotating already. Okay? Two field in the two halls. But they rotate in opposite direction. Hmm. A stationary magnetic field can be split into two fields, rotating fields, which is rotating at synchronous speed. Okay, clear? Now the stationary field. Now the induction motor respond to this field, each of these fields separately. Huh? and the net torque due to this field is equal to the sum of these two torques. Okay, this is rotating in say anti-clockwise, this is rotating in clockwise, opposite direction, equal magnitudes. Okay, so initially when you give supply to them, they are rotating synchronously in opposite direction. So net torque is zero, and therefore you can also explain that therefore single phase motors are not self-starting. Okay. Now, now if I rotate one of the field additionally, if I continue to rotate one of the field by external force or by additional force externally, then this the field rotation of this field will be higher than this. Then you have to create a difference of, okay, you have to create a difference of the speed between two fields. Okay, so this half of the field will be in the this is clock, this is anti-clock, this is clock. And if already my rotor is rotating in anti-clockwise direction, then they will be added if it is rotating in opposite direction. So this speed will be more. And what will happen then? We have already created a difference. This is rotating at higher speed than this. So the net torque will be generated, and net torque will be generated, and the rotor will continue to rotate. Okay. So this is based on this theory. You can explain how 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 rotor continue to rotate after after starting, because your rotor would be rotating in one of the direction, maybe anti-clock. So now this alternating flux is there, but this theory, because of the theory, there will be a net torque generation, and that will make rotor to rotate. So this is how even on just one alternating flux after starting of a rotation, okay, in one of the direction, you can remove the auxiliary winding and this motor continue to rotate. Clear? Okay, so this is there. Now if I see about the split phase motor, if I plot the torques, say this is very important, torque speed. Now we are plotting torque speed characteristics. So what will happen? Initially the torque will be like this. Then here at this point, your switch will be opening. Your switch will open. Okay. Earlier, both the windings will be there, auxiliary plus main winding. But after your switch get opened, which winding will be in the circuit? Only main winding. So this is the characteristics. So here only main, you can just have this dotted. So this is how the torque speed characteristics is there. So starting torque is about 1.5 times the full load torque. Starting torque is about 1.4 times the torque and the maximum torque is approximately 2.5 times the full load torque. Clear? So this is how there, and it is used applications. If you talk about the applications, the applications basically this is cheap. No? These motors are cheap. So where you find application, cheap means everywhere you can say. So like a washing machine, washing machines, uh, mixers, mixer grinder, that way mixers, uh, small drills, small drilling machines, and you can also have blowers, small blowers, like you can say vacuum cleaner type blowers. Okay, and small offices, there are many things which you have to do in the office. So office machineries, there you find it. So this is about the application of the split motor. Then what was the next? Next was capacitor. Actually, capacitor motors, and they are further divided in capacitor start, capacitor run motors. So we first see the capacitor start. Capacitor start. You can say induction motors. Okay, capacitor start, induction motor. Okay, capacitor start, induction run motor. You can put silently induction run motor. In silent it is. Okay. So the circuit is something like this. You have main winding. Okay. You have centrifugal switch, and you have auxiliary winding and a capacitor. So this is auxiliary winding, capacitor. This is main winding. Clear? And here there is a rotor. Clear? And this is phase and neutral. Okay. So this is the circuit of single phase motors. Okay. Can anybody now let us say the current through this is IM, IA, and this is I. Okay. The supply voltage is V. Clear? So if I plot the phasor for this, how it would be? This is V. Because of this capacitance, auxiliary current will be leading, not 90-degree, but something. So this is IA, and because of the inductance, IM will be lagging by some degree, and sum of these two The net current is I. Okay. Now, how it would be working? Anybody? Can you explain how it would be working? Hmm? See, there is a, you can adjust it to 90 degree by choosing proper value of a capacitance. By choosing proper value of a capacitor, you can adjust it, this theta. Okay, clear? As close as 90 degree, you can make it. As close as 90 degree. Okay. Basically, this auxiliary and main winding, they are displaced by 90 degree in a space. And in series with the auxiliary winding, we will be putting capacitor. Now winding has a resistance, so it won't be 90 degree, it will be something 60, 70, something like that. So, so we are putting capacitor and we are making the angle between IA and IM, that is phi A and phi M, basically to 90 degree. Okay, current will produce flux. So we can make it 90 degree as close as we need. Okay, and therefore what will happen now? Now what will happen? Rotating field will be produced.
Yes, sir.
Rotating field will be produced. Okay, and that rotating field will make to rotate the rotor. Okay, it will make rotor to rotate, and when rotor reaches to 90%, you can set the speed, reaches to the speed of around 70 to 80%. Huh? What will happen? CS opens, or I'll write current IA, IM flows by 90 degree. Okay, you can adjust close to 90 degree. Flows. So rotating field produce. Okay, rotating field produce. Rotor rotates, and when reaches to 75, 70 to 80% of its synchronous speed, what happens? Switch opens. Centrifugal switch opens, and what happens then? Only main winding remains in circuit, and rotor continue to rotate. Continue to continue to rotate. That is what we call as a motor. Clear? Okay. Switch opens and auxiliary disconnected. Clear? Auxiliary disconnected, only main winding in the circuit, and rotor continue to rotate. This is what we want. Okay. Now if I plot the motor characteristics, huh? Motor characteristics T upon speed, T versus speed. So something like this. Now the switch will get open at this speed. So it will be something like this. Okay. So here at this point, switch open. Clear? You can have a dotted curve just to understand the curve generated by main motor. So here auxiliary plus main is working. Here only main is working. Okay. So this is the clear. So this is my synchronous speed. I am not shown it, but you can show it. Synchronous speed. At that, the torque will be zero. So like this, you will have. Okay. Mm. Now this is the. Now if you compare the previous motor with this, the starting torque is about high. It is high and is about 3 to 4 times of full load torque. Clear? So here you have a higher starting torque compared to that previous motor. Clear? So that is the term, that is there, and it is costlier because you have to put a costlier compared to previous motor. You have to put an additional capacitor. The cost is increasing, so it is a costlier, but it has a higher starting torque. It is about 4 times the full load torque. Okay, and if you want applications of this, to talk about the applications where you need a higher starting torque. This is like a pump and compressors where you need a higher starting start. Pump and compressors like your ACs or the fridges. There you use this motor. Okay. Sometimes it is used in some machine tools that you will learn. You are in first year, so really difficult to understand and explain machine tools. Machine tools is a, there you have different types of machines and you have to run those machines. To run those machines, you need such type of motors. So sometimes the conveyors, they are, so these are the applications of, these are the applications of capacitor start, sorry, capacitor start. Induction run is a silent motor. Now I will save this. Okay. Now what I will do instead of, I will just select. Okay. Now here what happens, this is capacitor start, capacitor run motor. I will just capacitor start, capacitor run motor. Okay, capacitor. Now instead of, in, now here what I will do, what I will do, I will put a capacitor. I'll just here. Here I can put additional capacitor like this. Okay, I'll put additional capacitor like this. Okay, and I will call this as a start capacitor, and this will I will call as the one capacitor. So two capacitors I will be using here. Okay, so start capacitor and run capacitor. This is a start capacitor, and CR is a run capacitor, a running capacitor. Here, running capacitor. So what actually happens now, we are putting additional capacitor. Okay, so this type of mode here, running capacitor is permanently connected, is permanently connected, is permanently connected. Okay, uh, you can also call it this as a two value or a two value capacitor motor also. Some people call this as a two value capacitor motor. Okay, so like this. So actually auxiliary winding plus start capacitor out of circuit after centrifugal switch. Okay, CS now you just I'll put CP so that will make it clear. CP. So after centrifugal switch opens, which is around 70 to 80% of synchronous speed. Okay, so it will close initially. Okay, so initially current will flow in both auxiliary and IA plus IM both flows at 70 to 80% speed. 70 to 80% speed, CS open and auxiliary, and this happens. Okay, after that CR plus main winding permanently in circuit, permanently in circuit. Here, so what is the advantage of this? You get power factor. It is used for power factor improvement. So power factor improvement. But the values of this CR is small. The value of CR is small compared to CS. Clear? So CS is more than CR, that is not, and this is needed to have high starting torque. Okay, so that is there. Again, the you can for this uh, you can draw tracer for that, or I'll just draw the the torque speed characteristics for this. And here you have something like this. Okay, clear? So like this, but the starting torque is less compared to previous because the CR and these values are less than that. So it is around 2%, 200% of the full load value. The advantage it is a quiet. Advantage of this is quiet and smooth running. आवाज नहीं होता. Smooth running and higher efficiency. These are the advantages compared to previous all the motors. Huh? Okay. And the applications, if you talk applications of this pumping, air compressors, even fridges, refrigeration. So these are some of the applications. And as I told you, there are n number of uh, n number of actually calling this capacitor start, capacitor run motor. So but it is having two value. Sometimes only permanently capacitor start run motor is also there. So next class we will do that. We stop here. Or if you don't, have you got a class next? Or just allow me 15 minutes. Should I continue?
There is Viva, sir,
At what time?
from 11:15.
Okay. So do go.
There are two Vivas, sir.
Huh?
Two Vivas, sir. 11:15 and evening also.
We will also start Viva from next week, in the next week. Okay, in batches we will have to take because it's a huge students, large number of students. So we will start Viva next week. Anytime announcement would be there. Just a very small part of 10 minutes, 15 minutes left out. Okay.
Sir, will there be separate Viva for theory and lab?
Yes, there will be separate. So lab Viva I think over. Is it not?
No, sir. For X3 batch, it is on Monday.
Not started for expo, sir.
But we will have to finish the Vivas. We have just next week 4-5 periods, 97 students. So we will have to plan it accordingly. We may have to go on Saturdays also. Clear? So we stop here.
Okay, sir. Thank you, sir.